Welcome to episode 3 of our Scaffold DIA video tutorial. This is part 2 of a 2-part episode on loading data into Scaffold DIA. This portion will delve into the second workflow. For information regarding workflow option 1 and general background info, such as explanation of file types, please see episode 2 of the tutorial series. This episode will only cover workflow option number 2. As discussed in the last video, Workflow 2 allows you to create an elib chromatogram library from reference DIA data and then search experimental DIA data using that library. Note, this workflow requires that you have both reference data to be used in the creation of the library and experimental data that will be searched. On to loading data. Select the second option at the top of the workflow dialog. You will now see two expandable sections in the workflow dialog. One section to define reference parameters and one section to define experimental parameters. First, the reference library must be named and a save location must be defined. Click Choose to do so. Once the library is created, it can be reused as long as the chromatography does not change dramatically. Click on the heading for the reference section to expand it. If you have loaded data into Scaffold DIA using the first workflow, then the reference library creation parameter should look familiar. Start by defining how the library creation search will be carried out. You can either search your reference data against a FASTA file or an existing blib or elib library. In this example, reference data will be searched using a FASTA file. Note, when using a blib from Skyline, you have the option to add an IRT-DB file just as you do when searching experimental data. Again, this file is optional as IRT peptides are not required. When using an existing library to create a new elib, the existing library fragment tolerance must be defined. Since this search will be carried out against a FASTA file, there is no need to do that here. Select the checkbox if you would like to perform retention time alignment on your reference samples. This is likely only necessary if you have differences in chromatography between individual runs for reference samples. If you are creating a library from gas phase fractionated samples, you do not want to use retention time alignment. The next section contains common parameters such as peptide length, number of miscleavages, and tolerances. Set these appropriately for your experiment and instrumentation. If in doubt, the defaults are a good place to start. Next, any modifications of interest can be added to the search. Note, carbamidamethylation of C is added as a fixed mod by default. This can be removed if it is not applicable. As before, it is important to set the peptide FDR threshold appropriately, as once the search is completed, this cannot be changed. Define the data acquisition type that is appropriate for this experiment. This parameter must be set to match how the data was captured by the instrument. Windows can either be non-overlapping, overlapping with small margins, or staggered with significant overlap. Lastly, in the reference library creation parameters section, use the Add button in the top right corner to select the raw files that are to be used for library creation. Click on the section heading to collapse the reference library section and click to expand the experimental data search parameters section. Here, parameters controlling the experimental data search are defined. Almost all of the experimental data search parameters are carried over from the reference search setup. If you are creating a library by searching a blib or elib, you must define a FASTA file here. Since data will be searched against a FASTA in this example, this has already been defined. Make sure the digestion enzyme matches what was used in the experiment. Next, add the raw experimental DIA files using the Add button in the top right. If you have already set a processing directory, once you choose your experimental files, the yellow triangle should be cleared and data processing can begin. Select Load Data to start the search. Finally, note the two workflow buttons found in the lower left portion of the workflow dialog. The Save Workflow As button allows you to save all of the defined processing parameters to a workflow file. Once all of your parameters are set, click Save. This file can then be used again to start a search with the same parameters. This saves time when setting up a run and can help ensure consistency between experiments. To load an existing workflow file, select the Load Workflow from File button.